My other virtual machine, W2K8R22, is installing. Let's go take a look at its partner, 2K8R2-1. I could rename it, but I don't like doing that because it's not going to rename it on disk. So let's see what happens when we do that. So if I go right click on it and say rename, it's definitely not going to change the computer name in Windows, and computer name in Windows doesn't necessarily match that at all. I personally like to do it that way, just easier to keep track of everything. Potentially you want to give it a longer, more descriptive name, especially if it's something used for imaging or whatever, where the computer name might change quite a lot. But if I go into the host now and I go back to the configuration and go back to my data store and browse it, hasn't done anything to change the files associated with that virtual machine, so I'd be a little hesitant to do that. It's easy to lose track. Potentially you can rename the files and things in here, but that could be even more dangerous, and you might have references, for example, inside the VMX. You can change the folder name. You will have to unregister and re-register the VM first. Let's take a look though. Now that we're in the data store, let's see what makes up a virtual machine. So I've opened my data store, I've gone to the data store browser. I can also access that potentially through a WinSCP client if SSH is enabled to our host. VMware recommends that you don't leave that turned on all the time. And if we take a look here, you can see that I've got a .vmx file, which has the various configuration options for my virtual machine. We'll take a look at that file in a minute. I've got a VMDK file, which is my virtual disk. On this virtual machine anyway, it's 7 gigs and up to a maximum of 100 gigs. That's a little different from what I had chosen in my W2K8R2, which is still installing. And if I go over there, we'll see that I do have a file. And if I refresh, we should see, because the Windows install is proceeding, that it's growing in size. If we go back to 2K8R21 here, we've got the VMX, we've got the VMDK, we've got a couple of log files. You'll notice if you right click on one of these files, you can download them. We're going to do that with the VMX file. These logs are actually not useful. And we've also got VMXF file, VMSD file, and depending on whether the virtual machine has any snapshots, you'll see other files listed here as well. So I'm not going to get into all the details of all of them, but if we want to make copies of this virtual machine, if we need to distribute this, we could potentially download the entire contents of this folder. But of course, we may have references to items that are outside of this folder. For example, VMDKs that are listed with this virtual machine, but not stored in this directory. If we want to see those sort of details, we may want to download the VMX file. In this case, I'll just put it on my desktop. I'm going to overwrite another file if there's one there with that name and all those things, that's fine. And it's just a little text file. So if I go ahead and open that, whatever your preferred editor is, and Windows Notepad works just fine. If you look through here, you'll see the information about the network device that we're using and the network name that we're connected to, and details of, for example, you'll notice the media that is currently associated with it, my ISO file there for my installation, and other disks that might be associated with it. You'll see that the VMDK file is listed with a relative reference. If it's in the same directory, the directory name is not included. So if we were to move all these files, it would just find it. But if you add other VMDKs and they're not in the local folder, then they're going to be listed here with a full path. And that path is going to look a lot like what we saw for the ISO file. And you'll see that it actually has the ID of the volume where it's stored and then the full path to the file on that volume. That's going to cause us problems if those references are not resolved. That can also be a problem sometimes too, even just when your storage is working normally, or when you start making changes or whatever, it's maybe working a little differently. If you present snapshots and things like that, VMware might actually modify the ID of the data store, in which case those references might not work. It's best if we keep everything together. It's going to make your life easier, although you might have good reason to place different disks on different stores, but then you're going to have to manage that and be aware of it and deal with it. So we could modify that VMX and then upload it back to the data store. Let's try to avoid doing that if it's not absolutely necessary, but there's also some additional options that potentially you could set there. So if you did want to upload a new copy, you can just click on the folder and you'll notice we have the upload file or upload folder option if you want to upload a folder with all the files that go with a VM, for example, or a download folder. I'm going to go ahead and close the data store browser. So why don't we go ahead and open the settings for virtual machine and see what we can do after the fact. You'll notice there is an option that says upgrade virtual hardware here. I haven't yet created a VM in custom settings, but you can actually choose the virtual hardware version for backwards compatibility. So if we're ready to update that, we could. If I go ahead and edit its settings, you'll see we can set the memory, we can set the number of CPUs quite easily. Potentially changing these could cause problems for your virtual machine for the OS, depending on what drivers were installed, or potentially even the system would blue screen if it's like a really old version of NT or something like that. So you want to be a little careful with these. What's interesting is on more modern OSs, you can support hot add memory and hot add CPUs in a virtual environment. In a physical environment, that's usually a very expensive feature and one that still kind of scares me, and I don't know if I would ever actually try it in a box that claims to support it. But in a virtual machine, I'm pretty sure it's safe. But we have to have an operating system that supports it inside the guest. So for that, you'll see over in the options, we've got memory CPU hot plug. If your guest OS supports it, that's when these options will be available. Otherwise, it'll block them out. Notice, for example, that I've got CPU hot add, but I don't have CPU hot add and remove. But VMware does support that now. So if your VM OS supports it, then we can do it. So that could be quite interesting, and we could dynamically scale the resources available to a virtual machine without having to take it down. However, what we might find is that we don't necessarily want to go and modify these things all of the time and be adding and removing CPUs and trying to manage all that type of configuration. We have things like reservations and limits and the distributed resource schedule. Maybe it'll make that less necessary. Sometimes a virtual machine really starts to use all the resources you've declared. We don't want to over-declare resources. So this gives us an incentive to keep what you set, in terms of CPU and hardware down. And you can always potentially add them if you've got the right combination of components to bring the VM performance up without over-allocating resources and wasting them. Although VMware is pretty good about reclaiming that sort of thing, so it's not something you need to worry about too much, but be aware of it anyway. So we can manage our memory size here, we can set our CPUs as necessary. Depending on what you're running inside your virtual machine, the CPUs may incur a licensing cost, so we could specify whether we want to have multiple virtual cores per socket or just multiple virtual sockets. If you're paying by the socket, then it makes sense to maximize the number of cores per socket. By default, in earlier versions of VMware, it was only one, and people didn't always realize that. Now, this doesn't give you any extra performance. It doesn't give you any greater number of cores, just whether they're represented as shared virtual sockets or not. Check with your vendor on how their licensing policies work for your applications in a virtual environment, especially potentially in a multi-host virtual environment. If you're using things like DRS and vMotion, it'd be very useful to have your virtual machine float all over your data center. But if you then end up having to incur additional licensing costs every time that you do that, at some unknown point in the future, that could get very costly. So just be aware. We can set some video card settings here. You shouldn't really need to do this. There's no real reason to run super high resolution displays inside of a virtual machine. One of the things that could be interesting is if you want to do something more useful on your console, you could use direct path to present a video card to a virtual machine and have a virtual machine drive a monitor off of the back of the ESXi host. You're not going to be doing much in the way of vMotion at that point, mind you, without some reconfiguration of that VM, but these kind of things could be done. For virtual machines that need to communicate with the host at very high speed, virtualized storage appliances, for example, or maybe some sort of security device, or something that's going to participate with the hypervisor at having large volumes of traffic, we've got this high-speed communication interface. So we can enable it here if we want to. We've got the SCSI controller listed here. Because I said I was using Windows 2008, it said, well, you should use an LSI Logic serial attached SCSI controller. It might have recommended something else, a Bus Logic parallel SCSI or an LSI Logic parallel SCSI. If I want to add additional SCSI controllers, I actually add additional hard disks. If necessary, I can go ahead and click Add here and add all the various other types of devices that are supported or more of the devices I already have for network cards or drives. You can map a physical SCSI device into your virtual machine. Maybe you're driving some piece of industrial equipment or something. You could virtualize the machine and still have it access the outside world. We have something similar with the serial and parallel ports. So we can actually pipe out to not just the physical port on the host, but also to name pipes and networks and so on. Some interesting features for virtualizing things like data acquisition equipment or graphing and monitoring and probe type equipment and so on. So if you go over to the Options tab, you could change the operating system that's installed if you ever need to do that. You've done an upgrade or something inside a virtual machine. You can also specify how the toolbar buttons behave, and we can integrate with some scripts. As you start installing updates for VMware, eventually the tools will get an updates package. That only can be applied with a restart. What we can actually say is to have it automatically check for and upgrade the tools There's always the potential that something could go wrong, I suppose, with the drivers. For some servers, you might decide not to do that or to do it only inside, a designated change window. That's absolutely fine, and, you can apply that if needed. But for convenience anyway, you could turn this setting on. There's also the option to synchronize the guest time with the host. It may now be appropriate to turn this on. You'll really have to look at your application. For example, a domain controller, an Active Directory domain controller, should never be rolled back in time, not even by 1 second, according to people I've spoken to. It's just not supported. Active Directory inside virtual machines of any type, not just on VMware, is a sensitive and tricky subject for this timekeeping issue. There's about 100 pages of documentation on VMware's website on timekeeping best practices. And it really still says you could do it this way or you could do it this other way, but there's cases for both. You'll need to look into those for your needs. You shouldn't really ever need to access the BIOS of the virtual machine. You might remember when I opened the console of my VM, it goes by very, very quickly on a virtual machine compared to a physical host. So you can say the next time the virtual machine boots, force it to go into the BIOS. Again, there's really not much to change in there because we don't present the full capability of the hardware to the virtual machine. The simplified, generic hardware environment we present to the VM is not really a lot that you need to do to tune in there. But if you start getting into booting from the network and booting from CD or, doing some kind of multi-boot or something like that, maybe in those kind of cases you need to. So that gives us a little bit of an idea of what we can do inside the virtual machine properties, either before we turn it on for the first time or after. Just keep in mind that making changes there may impact the kernel configuration of your guest operating system. You might have to replace the HAL, for example, on older versions of Windows, going from a single to multiple processor. Or even if you go back, Microsoft recommends that if you don't have multiple CPUs, that you shouldn't have the multi-CPU HAL. If you do a physical to virtual import of a system that had multiple physical CPUs and you're bringing it down to one virtual CPU, then you should be looking at changing those types of settings inside the guest. So changing those things, you'll have to test carefully for how your application is going to behave and whether you're going to get the appropriate performance and everything out of it.